So this question is about simple harmonic motion, and it's pretty straightforward and quick. It's the last question in the multiple choice section, so hopefully candidates would have had time to get this done. We're asked which one's not correct. So looking at this, the speed of the particle, so I'm going to go through all of them and determine hopefully that 3 are right and 1's wrong. The speed of the particle is maximum at time t over 4. So I can see from the graph that at t over 4 the displacement is 0. And I know, I've talked about this before, where you have a pendulum or something moving in SHM, minimum speed at the maximum displacement and then maximum speed at 0 displacement. So that's true, A is true. Then potential energy of the particle is 0 times 3t over 4. So potential energy, I'll be looking, it doesn't tell me what sort of simple harmonic motion it is, but maximum potential energy is when it's got minimum kinetic energy, which is at maximum displacement. It's not at maximum or minimum anything. So B is not correct. It's partway between maximum and actually looking at the graph, that is it looks at 0. It's not a particularly good graph. This is taken directly from the paper itself. The t over 4 isn't quite where I'd expect it to be, because it should be halfway between the t halves. So something's gone wrong with the actual formatting of this. So actually 3t over 4, potential energy when it's in the middle, if I'm assuming it is actually at the middle, potential energy could be considered to be 0 there. So that could be considered to be true. Acceleration of the particle maximum time t a half. Well, the acceleration is proportional to the negative of the displacement. So that's true. The restoring force acting on the particle is 0 at time t. Actually, that is incorrect. The restoring force at the particle at 0 is a maximum at time t. Maximum displacement, if A is proportional to the negative of the displacement, it's in the opposite direction, F equals ma, means that F is proportional to A is proportional to negative displacement. So at looking at the graph, at 0, F is a maximum, A is a maximum, displacement's a maximum. At t a half, it's a negative maximum, so F and A are maximum, but in the opposite direction. So D is the one that's incorrect. But that formatting of the graph actually meant that I incorrectly assumed that B was wrong, because I was looking at where it was on the axis rather than looking at the value.